Okay, so today we are going to talk a little bit about, or do a couple examples of how to get the electron configuration for elements. So we have our periodic table here. This one has the different blocks listed. So over here you have the S block, over here you have the P block, and over here you have the D block. So what those mean are those elements end their configuration in that block. So the last electrons that you put are going to be in that particular orbital, either the S, the P, the D, and then down here we have the F, but we're going to do those later. So if we were going to do the electron configuration for hydrogen, which is this one up here, so we would write it's in the first energy level. So the big number is the energy levels. So this is first period, second period, third period, fourth period, fifth period, sixth period, seventh period. So we would write 1, and then it's in the S block, and there's 1 electron. So we'd write it as 1s1. 1s1. Okay. Get a little bit darker. 1s1. All right, so if we wanted to go to helium, which would be the next one. So helium, helium's over here. Technically it's in group 18 with the noble gases, but really it fits right here because it's in the S block. And we would write 1s, and now there's 1, 2, so there's 2 electrons. Okay. We put it over here because it acts more like a noble gas, because remember that first energy level, that first ring around the nucleus, only holds 2 electrons. So it's technically has a full shell. Okay. So now if we were to keep going, lithium would be, we always start back here. So it has 1s2 because it has those electrons in the inner shell. And then now we're in the second energy level, so this will be 2, we're still in the S, and there's 1 electron there. So this is 2s1. Then if we go to beryllium, that would be 1s2, and then now we're at 2s2. Okay. Then if we go over to boron, that would be 1s2. Again, we start back at the beginning. 2s2, 1s2, 2s2, and boron's over here in 2p. So we'd write 2p1. 2p1. Again, the s orbital only holds 2 electrons. The max it can have is 2. The p orbital will hold 6. Okay, so we could go 1, 2, 3, 4, 5, 6. So if it was 2p6, that would get us to neon. Okay, I want to skip down. Let's skip down to one of these. Let's say scandium, which is Sc. Okay, and that's in the D block. So we're going to go 1s2. Again, that gets us to here. Then 2s2. Then 2p, 1, 2, 3, 4, 5, 6. We're trying to get to here, right? So 2p6, we're not there yet. So then we got to go to the third energy level, so that's 3s2. Then we're going to go 3p6, which is there. Then 4s2. And now we're in the D block. Notice the D orbitals are 1 less than the period that they're in, the number. Okay, so instead of this being 4D, we actually write 3D, and since we're stopping here, 3D1. Okay, if you go all the way across, there's 10 that hold, or the D orbitals hold 10 electrons. So the max you could have by a D, or the exponent here is 10. Okay. Now, one way to check yourself to make sure you did it correctly, if you count up these exponents, so 2 plus 2 is 4, plus 6 is 10, plus 2 is 12, plus 6 is 18, plus 2 is 20, plus 1 is 21. And scandium is atomic number 21, so that means that we did it correctly. The exponents added up should equal the atomic number of whatever element you're trying to do, because it represents the electrons. So I hope this helps. We will do some more examples later, but this should be a good start.